optimize, and expand in any direction.
Targeting distributed system by birth.
All right, let's get started. Who's awake? I got you a little awake with that wave, right? I got to tell you, that was not my idea. That was my colleague Simone's idea, who did this before, but she did it in the football stadium, which was kind of cool, I'd say. So now we're awake, I'm going to test whether you're really awake by asking you a question. And this question is, what do you see on the screen behind me? Where was this picture taken? If you know, shout. Ooh, SpaceX, the first one, right away. Yes, this is a picture from SpaceX, and well, it looks kind of cool, right? There are all kinds of screens. You see a video feed of a rocket, probably. So if anyone is building distributed systems, it's probably SpaceX. So that sounded interesting. So I browsed through their career pages yesterday to find out like what type of profiles are they looking for. And they're building stuff in all kinds of languages, Java included. But I also saw JavaScript in there. So it may be possible, well, it is possible that some of the software at SpaceX is built in JavaScript. So it may be possible there's JavaScript running in space. Which sounds kind of scary. But on the other hand, the further away from Earth JavaScript is, the less damage it can do, right? Just kidding, I love JavaScript. So when I created this talk and I first practiced it, I had about 2 hours of material. Who has 2 hours here? Well, there are some, but most of you don't have. So, but I shortened it, and we should be able to do it in 49 minutes. So we should also call this the good parts that I borrowed from the JavaScript.
So this function.
JavaScript, but only the good parts. Or we could call it networking 101, because I'm mainly going to dive into networking. Or even how the internet works. So before we dive into the good stuff, let's start with why. Why this talk? Why are you all here? Because I'm almost sure that almost all of you are in some way involved with building distributed systems. I believe microservice is the popular term for it now. So even if you're developing a static website, it's still a distributed system involving a browser, a network connection, and a web server. And in this talk, we're mainly going to talk about those network connections. So my name is Bert-Jan Schrijver. I work at Open Value. I was checking if my colleagues are awake. 2 of them are. I also do some stuff for the NL Jug. Do we have people from the NL Jug in here? Yes, that's a loud bunch, right? So as you can see on the picture as well, I wave my hands a lot. I'm also on Twitter, where I spend way too much time. So I'll share my slides there afterwards. And if you have any questions afterwards, feel free to reach out. I'll probably reply way too fast. So the next 45 minutes, we already did the why. So we're going to start with some theory, because you can only fix something you can understand, right? And so the first part will be theory, and the second part of the talk will be a bit more hands-on. So we're going to talk about what are distributed systems, and why are they difficult, and why it's difficult to work with distributed systems. I'll share I'll dive into networking 101, so how do networks work. I'll share a structured approach to debug distributed systems. There'll be lots of demos. Hopefully you have time to share some war stories about things that went wrong in the past. And every story needs an end, so this one has a conclusion as well. So this talk is mostly about debugging connections between systems and about the messages that are being passed. So let's start with what. What is a distributed system? Well, if you want to know what something is, you go to Wikipedia, right? So that's what I did. Wikipedia says, it's a system whose components are located on different network computers. And they communicate and coordinate by passing messages. So we're going to talk about components on different computers that talk messages. So what are characteristics of distributed systems? Well, they have multiple components running concurrently in different places, maybe even different parts of the world. There's no global clock, which doesn't sound like a big deal, right? Who cares about clocks? Well, stuff like logging and in-order delivery, maybe metrics depend on clocks. Time in distributed systems, especially when you're distributed across the world, is not really reliable. Actually, because quartz crystals that are using these clocks, they tend to drift. And components can fail independently of each other, which means that at some point, if your system is big enough, you can be pretty sure that at any point in time, at least some parts of your system are broken. And as a result, distributed systems are harder to reason about, harder to fit in your head. And as Martin Kleppmann says, he's the author of Designing Data-Intensive Applications, which is an awesome book if you want to learn more. He said it's fundamentally different from writing software that runs on a single computer. And the main difference is that there's new and exciting ways for things to go wrong. So we're going to look at those exciting ways, right? So why do things go wrong if we build distributed systems that are difficult to reason about? Well, one reason is that we tend to make false assumptions about those systems. These assumptions are called the fallacies of distributed computing. So there are things that we tend to make wrong about distributed computing. And these were made by a couple of smart people at Sun Microsystems a while ago. And they're describing false assumptions that people who are new to distributed systems typically make. Me included, and you included probably as well. So there are, I don't know, about 8. And they're all false. So networks are typically not reliable. There may be, I don't know, water in your network closet causing your switch to fail. There's always latency. And latency may have impact in messages, timing, etc. Bandwidth is typically not infinite, especially if you're working on mobile connections. This may have an impact on the experience of the end user, for example. The network is secure. Well, there's an interesting story about this. Google has quite some data centers, right? And Yahoo as well. And these data centers are connected through fiber cables that, for example, run below the water in front of the coast. And there's this rumor that NSA had access to data between data centers from Google and Yahoo. So what they did, they dug up a cable, they cut open this cable, put a device in between, and from then on had access to all the data flowing over these cables. So this was before Google and Yahoo had encryption on the traffic between their data centers. So this is one of the reasons why you should encrypt internal network traffic as well, because it may not be as internal as you think. Network topologies tend to change, something that now may be really fast. So you're making a database connection to something close, you have almost no latency, and for some reason the cable breaks and now you're routed through the other end of the world. And now you get 100 millisecond latency on every query. So what is 100 milliseconds? Not that much. But if you're doing 1,000 per second, then it is. There's typically more than one administrator, and different people do different things. It costs something to transport data. It may cost time, it may cost bandwidth, it may cost you money. And the network typically is not homogeneous, which means that some parts of the network may be more reliable or quicker than other parts. So knowing that these systems are difficult to reason about, knowing that we tend to make false assumptions, you may ask yourself, what could possibly go wrong? Well, let's start with something that's probably a long time ago for many of you. Basically, everything that can go wrong is in the OSI model. How many of you have recently studied the OSI model? How many of you have done it like 5 or 10 or 20 years ago? Exactly, I had the same feeling. But basically, this is a good indication of the things you can think about that can go wrong in distributed systems. So let's look at the TCP/IP conceptual layers, because there are only 4, and I only need to explain 4 instead of 7. So the application layer is typically protocols like HTTP and DNS, and also TLS that run basically on the top layer. The transport layer, we're talking about TCP connections, UDP connections. The network layer, we're talking about IP, so routing between machines. And the network interface is physical media, Ethernet. So what can go wrong? Basically, things can go wrong in all of these things. Well, typically, we don't influence all of these things. So has anyone ever had a job interview and had a question that started with, what happens when you type google.com in your browser's address bar and press enter? Well, I'm going to ask you all this question. What's the first thing that happens? Shout.
You know your business better than anyone, right? So why not build an app to run it with Base44? This finance app solves your business headaches, tracking.
Well, DNS happens, but stuff is happening before. TLS handshake, that typically happens, I guess, after DNS, but way earlier. Think about your local machine. Somebody said keyboard, and that's actually quite well in the right direction. So what happens first is, well, you start typing, right? So you press down a key, and then it depends whether you have a USB keyboard or like a PS2 keyboard, if those even exist. So this typically, when you press the key down, a current flows through your key, triggering probably an interrupt in your system somewhere, instructing the system of a key down press. So why I'm asking this? Because, well, your G key can be broken as well, right? And then this doesn't work. So if you find this interesting, there's this site on GitHub, github.com/Alex, what happens when, and he describes this process in about 10,000 steps. So if you ever have like a rainy Sunday night, you feel bored, you may go here. But what happens when we type Google in our browser address bar? Well, let's take my notepad and start drawing. So let's assume I'm sitting at home behind my computer. This is me. After 4 days of DevOps, I look kind of skinny. This is my laptop. I'm typing www.google.com in my browser address bar. Press enter. So first thing that happens is my browser is going to parse the URL. It sees www.google.com, then it's going to check its HTTP strict transport security preload list, which is probably in Chrome, and probably it says you can only access google.com over TLS. So now I'm going to check my local DNS cache. Do I have an entry for google.com? Let's assume I don't. And then my laptop is going to make a query to my provider's DNS server, which is the first time I'm stepping outside my local network boundaries. I'm now going to connect over the internet to my provider's DNS server. So my computer connects to my provider's DNS server and asks it, can you give me the address for www.google.com? So let's assume, we're making lots of assumptions, that my provider does not have the address for google.com. Well, then it needs to ask the authoritative source, which is probably somewhere in a Google data center. So there's a DNS server there, my provider forwards to Google, Google replies, oh, well, it's address 1234. And then my DNS provider replies to me, and now my machine knows it needs to make connection to 1234. But we know more. We know that we need to go TLS because it was in the strict transport security preload list. So we're going to make a TCP connection to port 443 because it's a TLS connection. And this connection is going to go through some load balancer at Google probably. So on top of this TLS connection, TCP connection, we're going to make a TLS connection because it's going to be encrypted. And on top of this TLS connection, we're going to do an HTTP GET request for google.com. So it's probably safe to assume that Google is big enough that they have some kind of service registry in their network. So the load balancer then asks the service registry, tell me where I can find the machine that handles HTTP requests for google.com, which is probably a Kubernetes cluster or a Borg cluster at Google. And there's probably some ingress load balancer in there that talks to a service registry as well. So it asks the service registry, let me know which internal host I need to go to handle HTTP requests for google.com. It connects to some internal host. On this host, there's probably a Kubernetes pod running, and this pod probably needs some database access to connect, so it connects to a database, fetches some data, and then replies with the HTML for google.com, which travels the same route all the way back to my laptop with the HTTP response. So the steps we just described are make a connection. So this is both IP and TCP and TLS and HTTP. So we almost had the entire OC model. Make a request, and then parse the HTTP response we get. Simple, right? But the point is that things can go wrong in all of these arrows and boxes.
Yeah, I'm an AI, but I'm here to talk apps. Real apps you can build in minutes with Base 44. This finance app solves your business headaches, tracking in.
So you may ask yourself, where do I start when something is wrong? Well, here's an approach I've adopted over the years. It's not necessarily the right one, the best one. It's one that works for me, and it may work for you as well. So it's a couple of steps, and we're going to look at them in more detail soon. So it's about observing and documenting the situation, creating a minimal reproducer, start deepening on the client side, check whether the network connection works, so check DNS and routing, check the actual TCP or UDP connection, inspect any traffic or messages that are flowing, debug on the server side, and hopefully you find out what the problem is, and then in the end you can wrap up and do a postmortem. So let's start with step 1. Observe and document. So think for yourself, what do I know about the problem? Something is not working, which information have I gathered? Try to enrich this information. Inspect any logging you have, errors, metrics, tracing of requests. And then draw on a whiteboard or a piece of paper or a napkin, draw the path from source to target.
是三千。压抑吧，什么鬼？
And think about what's in between and focus on details here, because the problem may be in a system that you don't control. There may be some firewall or proxy in between that's messing with your HTTP headers. So make sure that you focus on details there. And then ideally also write this down in some sort of document. So this document helps building insight and also helps you to transfer knowledge to others. Whenever you need to onboard somebody else on your problem, you can give them a document and have them up to speed in 5 minutes. And this is also the basis for the final step, which is the post-mortem, where you look back and describe what went wrong. And think whether you can reproduce the problem in a test, in a unit test, an integration test, for example, by injecting errors on your local site. So tools you use here, maybe a whiteboard, documentation, logging, metrics, tracing. You could have a look at the Open Tracing project, tests, or fault injection systems like Jepsen. So if you're building distributed systems, Jepsen is an awesome tool to inject faults, latency, error, etc. And the result may look something like this, or completely different. So step 2 is to create a minimal reproducer. So a minimal reproducer is something that can reproduce the problem with the least amount of effort and time. So your goal there is to maximize the amount of debugging cycles. So you've probably all experienced that a colleague says they have a problem. And I said, okay, can you show me the problem? And I said, yeah, I just need to go here, click here, log in there, download this, copy it there, run on my desk 4 times, and then press this button and do that and telnet here, and this is the problem. And it takes them 15 minutes to show the problem. So if it takes you 15 minutes to show the problem, you can only try 4 times in an hour a solution. If it takes you 1 minute to demonstrate the problem, you have 60 tries. So the goal is to maximize the amount of debugging you can do. And also, you probably hate waiting, so it also helps. So focus on short development iterations and quick feedback loops there. And get close to the action. So try to get as close to the problem as possible. If it's happening on some remote server, you may need to go to the remote server, log in there. It may help to, I don't know, build a simple Java app or a shell script that you can run somewhere that's close to the action. Getting close to the action may also mean that you need to be close to the target machine, for example, by jumping there over an SSH tunnel. Who knows about SSH tunneling? Oh, that's about half of you. Okay, so then for half of you, this is going to be boring. For the other half, let's do a quick demo. So let's say that I want to debug something that runs on my web server, on a remote web server. And I don't have access to this because it's a firewalled or internal port. So if I now, is this readable on the back? Yes? Okay. If I telnet to my local machine on port 8080, well, there's nothing running now. But let's say that I want to debug something that's on a remote machine running there on some internal port that I can't access. To demonstrate, let's abuse the OpenValue web server. So I'm going to set up an SSH tunnel that will open a local port, 8080, so this is local on my machine. Then I'm going to jump to the web server, which is the remote server. And over there I'm going to connect to localhost. So this is not this localhost. It's the local host on the remote machine. And it's going to connect to port 80 there, because that's where the web server runs. And let's log into the remote server. So now if I telnet to localhost 8080, I get a connection. And I can even talk HTTP. You do this every day, right? Oh, and it says me, buzz off, you need to be on a TLS connection. But still, I got to connect to some remote host. And obviously this is a trivial example because this machine is also reachable from the outside. But you may use this to use some machine in between to jump close to the action to, for example, get a connection to your database server. So tools you use here, maybe your IDE, shell scripts, SSH tunnels, curl, whatever you can do to get a quick reproducer of a problem. So next step is to start looking at what's happening on the client side. So let's assume that a connection is something between a client and a server, right? Or a consumer and a producer, but there's typically two systems involved. So focus on eliminating anything that could be wrong on the client side.
今晚的白色，前天地贼夜。我本来是想要买 ABS 的设备，不过因为预算不够，所以就买一个经济型的。这台是底下来，因为我觉得底下版本的话，你要 ABS 它还是挺危险。但底下可以帮助你更快的刹车，但如果没有 ABS，它的缩时的问题也就非常。我觉得这台车它一中速的时候非常的省力，你不用花太多力气就可以把它累死。有些人可能会觉得这台车挺长，但我觉得它其实还挺好看的。其他颜色我不好说，不过配色的话，我觉得它是有点神秘感，这种利落帅气的感觉。你说，为什么我安全帽要放在脚踏垫上，不放到这个后备箱？后备箱听起来也是很大。那他卖车的时候也是说，后备箱可以放下全罩式安全帽。不过这会对比我发生，其实你有觉得全罩式安全帽是放不下的，要确定有些规格的才放得下，但是网络上没人确定它的规格，不然的话会遵照这样子的程序。 就是说，但是让自己来好让自己看到里面，或者说是名字，或者是说程序员在他们就是在那里面没有人高兴，所以就开始里面的角色，为什么觉得他这个话觉得就是哪里面还是有选择方式选或者在一些礼貌上。还是这个指甲，尝试是吧？你最喜欢体育的，因为体育的话，看的那些就是比较不够，然后就是可以，就是看他们需要这些游泳的话就会很难这样才比较去他们去那个一个女生去就是这种东西。虽然说当然啊，这个你成绩不过你有的时候你去跟一起去借钱，那个的话你就可能看不上他。那你有空的时候你就要学，然后体育生当中你每组就是体育运动不够的这个情况，也许是一个很遇过，然后家人就经常就说，然后我觉得你这个就是让很多怀孕的状态啊，就是非洲上不仅要求要会讲还是因为这样子咱就可以拿方式比较多，就是可能那个要上收藏才这个产品上面，这个产品学校，我的结果作为生意的话，应该是因为我家厂那边也干，去把它分享，就是拿这个工具做那个需求，根据这个产品的就是如果这个产品做好，就是它给的功能是在边，把你去介绍那个。他会来做的事情。应该是说，如果你觉得这个东西那就是尝试解决。那如果你这个是大概20年前能给到我那比较大的可以。你说的如果也是看看，然后让我讲这个，你就是方向，那就开始，这个是要求很好。对，所以才要针对你的检查，对很多事情都需要去就是我们很多选项都还没有语言是的，就是而且之前看成绩话，这个工作呢是这个不是很好，会影响就是你不知道就能正常的去有 如果的话，看起来就是好像如果其实可以，因为那你需要付出的劳动力的话，就代表一定要去运动，然后去运动，然后就能对你的身体的健康有帮助。虽然说它好像看起来没有什么成绩，不过你休息的时候不是都会自己自学吗？你自学的话就不用怕你之后没成绩，因为你有空的时候你都要学习，然后肯定会帮助你回国自己一个足够的那个也许是个不错的选择。我有想过，因为家人是推荐我做销售，不过我不确定自己口才好像不太好，然后不知道能够把那个商品卖出去，还是说他有什么特定的要求，一定要我把哪一种品牌的才卖出去？因为这种品牌它给我们的 bonus 比较多，所以可能会比较让我们 focus 在这个产品上面，去对这个产品进行推销。但我觉得，如果做一个生意的话，我应该是会哪家厂商给你的 bonus 比较多，你就去帮他推销。可是，然后就根据客户他的一个需求，根据这个产品品质来做推销。如果这个产品不好，但是他给的 bonus 比较多，那我们去推销卖给这个客户，我觉得他是不太对的事情。应该是说，如果你觉得这个东西很好，
So think about, am I connecting to the right host at all?
are we connected
Do I
to the
send
right
the right
host?
message? And do I receive response or not? And this is not much different from local debugging you would do on your local machine, apart from the fact that the client could be running on a remote machine as well, right? If it's some service that has a client that you're trying to debug. So try to get as close as possible to the network boundary to figure out what's going wrong, because there may be the message may be corrupted somewhere in your client already. And is the issue already present when you receive the response from the other end? Or do you somehow corrupt the response when you're getting it back because I don't know, your JSON deserialization is broken? So tools you use here are your IDE, a debugger in your local client.
我觉得重点应该是，就是在家里待太久了，可能会对自己的工作能力会产生点疑问。那虽然说你有这样的工作能力，但你不确定你能不能把它发挥出来，所以你在进行工作的时候，就会觉得自己好像能力不太行，那你没有办法把你自己的能力阐述出来，这是一个比较严重的问题。但是说你对于你自己的信心会大打折扣。对我的不建议长期这样子的原因，就是因为可能人也是需要有一定情绪的养分，纯是情绪的东西，可能你需要有一点社交养分。如果我长期孤独的话，那可能会失去人生意义。这个可能也是因为我希望自己的爱人在之前在公司做实习的时候，不会觉得很痛苦。真的是，现在你至少还有跟别人进行一个互动。如果只是一个人这样子默默写代码，然后完成自己录，可是缺少了跟别人去进行交流的过程，可能觉得自己好像在这个世界上面就是面对一个空壳。不知道没有什么样的教育，非常的空虚。这种开始现在的人才会跟工作的经验，现在是比较发展之后，可以让创新的就是这样的发展，慢慢把自己记住出来，就是一种比较严重的问题，关于刷的对人的事情，大家可能 对我的这个立场是这样子，我觉得就是这件事上了实际的国际主义动作是一种像一个这样的就讲话，还是自己可能也是让我像自己的爱人的事情在公司做事情时，我也觉得很痛苦，所以是二是一个方式通过去采访他在地方，可是缺少跟别人去进行交流的过程，我就觉得好像都没时间上很真实。对啊，那在最近几个月之后，碰到比较多的感情，就是回到家里面高冷干，就是非常做家事之后的意思，然后自己去看见这样的过程当中，我发觉自己对城市而言，好像也不是那么的有兴趣，就是说反而在制作影片，然后在分享自己刚刚学刚刚学的这个过程，感觉比较舒服，比较自在，所以我也不确定之后是不是在业余的时间会去做尝试对 smart code。也许我会把这些时间拿来录作是给片说不定。因为现在不是有很多新兴企业，像是 YouTuber 还有 YouTuber，但是非常新奇，所以我不一定要自己做这项路。那我也非常感谢写程式能够带给我比较多的逻辑，然后能够带给我比较多的困难对自己挑战，让我呢不太去惧怕这个未来会面临的一些问题。虽然人际关系的挑战还是有的，我可能还是要去克服这一点，就是人际关系挑战。在接触自己的时候，碰到很多问题，都将高比较正常，然后做家事情，还有自己去看的过程当中，发觉自己的知识而言，好像就是就觉得，因为在做影片的话，要分享自己看看去的这种过程，他们主要说是在这里，我也觉得这都是在业余的时间面对这种考试的参考，也许会把那些知道的所以他们是有很多实际上是很可以做的，我们非常学习，所以我们不要自己是这样。那我也非常感谢你们，是从是刚带给我比较多的过程。那么再说，再来说一下这个事情，就是说，如果我选择去诠释这条路，就必定也会去。那我觉得这还是挺实惠的，毕竟因为情感的羁绊在这里的话，我觉得好像不是那么坏，好像有一点那有人可能会问说，那你为什么你的职业不是我的 computer science？那为什么不找一些 computer science 工作的？那就是因为我的家乡里面这个经济刚好是最小的，然后也不太会失去，所以如果如果要找的话，就是得到法律层的工作。那这个面临的问题就是说，我来到这里的话，不是就为了去考虑一家 如果我再回去的话，那我就有点背道而驰。那我有一个另外一个 option，就是说，因为我家其实离大陆是挺近，那所以我其实也可以去那里找工作啊，为什么不去那里找？是没错，那也是公寓老师，不过现在感觉他们人才方面他是不缺的，所以还有很多人才可以竞争。那么他开出来的岗位几乎都是3到5年的经验，所以我现在只有1年的经验，那也不太可能会离职，对吧？他是有开那个实习生的岗位，不过实习生的岗位他就只供学生去进行投递。那我是一个已经毕业生啊，毕业1年的学生，其实我也没有办法去进入到这个位置。那就基本上跟这一块陆地去告别了，除非我先去应任一个 IT 的公司，但不做 IT 的位置，先去做他的作业员还是什么，然后等到我几年之后慢慢晋升到 IT 的位置，也是可以的。那你这可能都是我的梦想，所以我觉得也没有什么动力去做这个。其实是像通常会找一些考虑的参考书的话，就是我的家乡里面这些本土导文至少也不太会适应，所以如果如果要找的话，就是肯定会到调理成人。但是由于面临的问题，就是说我要到这里的话，不是就为了去家人。如果我再回去的话，那我就有点背道而驰。那我有一个另外一个 option，就是说，那我们加入这个mandatory 所以我其实也可以去那里找工作啊，为什么不去那里找？是没错，那也是工作找工，不过现在感觉他们人才方面还是不缺，所以还有很多人才可以竞争。那他开出来的岗位几乎都是3到5年的经验，所以我现在只有1年经验，那也不太可能会离职。对啊，他是有开那个实习生的岗位，不过实习生的岗位他就只供学生去进行投递。那我是一个已经毕业生了，一个的学生，其实我也没有办法去，所以